Good morning, students. Today we are here again together with one more lecture, and today's lecture is about enzymes. We have learned about amino acids and proteins, and yesterday lipids as well. I hope you have understood how lipids are triesters, and you are learning your lecture and also making your notes. Uh, Today we will discuss the next topic, which is basically um, enzymes. And in this topic, I will teach you what are enzymes. Um, but before we start our topic, I want to clarify a few things because there is some confusion about the tests. So there are two tests. One is the ninth and 10th chapter chemistry 2, Sunday, 8 p.m. And one test is of sixth chapter alone, chemistry 1, and that will be taken on Wednesday, 8 p.m. Tests will be taken through a website. Of course, I will make a test, and from that through that website, you will be able to take the test. You will receive an email from that website to which I will register your emails to into three classes: Improver, 12 and first year. Improver will take all the tests, both inter and first year. Inter will take all the tests. First year alone will take first year's test only. Okay? And if you don't receive that email on Thursday before 8 p.m., then you have to contact me on my WhatsApp number because that means your email is not registered with us. Number one. Number two, your email will not be shown. Okay, nobody will except me. Nobody will have any access to the email address, so it remains private. So when you receive an email address from the website, you will have to link. You have to just follow the link, and there you give your name. Okay. So what will be seen on Facebook or result is will be just your name and your score. So email remains private in that if you guys are worried about it. Okay. I received many emails and it was a very tough job to collect them all. But still I am waiting for many students to send me their email addresses. This process must complete before Thursday 12 p.m., which is, I guess, tomorrow. After which I will close the groups and I will submit those email address to the website, and the website will definitely mail you, and you will have to follow the link to that. So I should get all the emails by tomorrow. Let's say 5 p.m. tomorrow or 6 p.m. tomorrow. And once I lock the group, then it will be difficult for me to add the students afterwards. So in case if you have any friends who don't know about this test, please inform them. All right. It will be a demonstration test. Let's see how it goes. Question will be mine. I will type the questions into a website, and the website will just provide us a platform to you and me to interact with each other. All right. Let's see how it goes. If it goes good, we will try to follow it and have more questions. Okay. And you will have a time limit like 8 p.m. to 8:50 p.m. So I will request all of you to ask your parents to monitor how you give the test. They should monitor that you're not using a calculator or a textbook or anything. I trust you because without trust it is not possible. I hope you will not hurt your future anyway. Okay? So prepare for the test. It is Sunday and it is on uh, Wednesday. Okay? So by Thursday we close the email so that if there's anyone who hasn't received the email, he can text me and I can fix that as well. So now we move with our lecture. Our lecture is about, today's lecture is about enzymes. And I think I have taught you in chemistry about catalysts. If you remember, all the improvers and all the students of class 12, I have taught you about catalysts, what catalysts are, what catalysts do. Catalysts basically provide a different pathway for the reaction. If you know, every reaction actually has an energy of activation. When you know this, I'm just repeating the lecture from class 11, and we all have taken those lectures already. If you guys remember, catalyst only provides, it lowers the energy of activation. When we mix two reactants, the reactants collide with each other. These collisions provide some internal energy, but that internal energy is not enough to convert the reactants into products. If you remember those graphs, there's always a minimum amount of energy called threshold energy, and below which the reactants will not stick together and make products. So in that threshold graph, a part of the energy comes from the collisions, but the remaining energy is taken from outside. It's called energy of activation. So reactions with a high energy of activation always proceed slowly because absorbing energy takes time. And reaction with the low energy of activation proceed faster. It will also be my lecture on the 8th chapter in class first year as well. So a catalyst does what? It lowers the energy of activation. A catalyst is a chemical substance. It lowers the energy of activation. And enzymes are also catalysts. The difference is that they lower the energy of activation for biological reactions, which takes place inside our bodies. And chemical catalysts, they are used in laboratories. But funny thing is that the enzyme, the catalyst enzyme, they lower the energy of activation a lot as compared to the normal catalyst used in the laboratory. Let's start with the enzymes, and here we go. There are many biological reactions which are taking place inside our bodies. First, digestion. Now, digestion is a huge process. I will be teaching you, it is our last topic in this chapter anyway, that how food from mouth until the large intestine, how the nutrients are broken down, larger molecules are broken down into smaller molecules into further smaller units. These are biological dissociative reaction. Somewhere there is oxidation taking place to break the chemical, somewhere reduction, somewhere there's a hydrolysis. And there are different kind of reactions which take place inside our body just in digestion. And it would have been not possible if there were no enzyme in our body to carry out the process. Please learn about enzyme properly so you may understand digestion. If you are from pre-medical, you will have no issue. But if you are from pre-engineering, you need to focus here, man. Okay? So digestion is a biological reaction which takes place inside our body. It is just like reactions in the laboratory, but laboratory is different and in our body is different. Okay? Then you say respiration. Now, respiration is not just breathing in and breathing out. It also has a lot of chemical changes alongside this respiration process. Again, enzymes are required. Metabolism in our body. Metabolism is not one reaction; it is also a group of reactions which take place inside our bodies. Okay, our bodies are machines. Okay, our bodies are biological machines. Okay, so we are working a lot. I mean, we are tremendous machines. Even human has made a lot of machine, but has been unable to make a machine like us. Okay, so we are evolutionary kings, and we have a lot of chemical processes happening in our bodies. The metabolism is just a general name to those all different kinds of reactions. And then muscle contraction. No, muscle contraction, how the muscle is going to work, how they use the energy, you know, how does the ATP form from glucose and all this. These are just few types of biological and chemical reactions which take place inside our body, and they're happening all the time. Even right now, I'm talking to you. Many of my many reactions are taking place in my body. And if you are a student of biology, you know what I mean. But if you are from engineering, you try to focus, okay? So what are enzymes? Enzymes are catalysts which speed up those biological or biochemical reactions inside our body. Got it? Yes? Enzyme is a name of catalyst. For example, let's take the example of H2O2, hydrogen peroxide. If you want to break it into H2O and oxygen, the energy of activation is 18 kilojoule per mole, which is a lot. So if you want to break H2O2 in laboratory without catalyst, 18 kilojoule will take a lot of time to be absorbed. It will be a slow reaction. But with a catalyst of let's say iron Fe, it will come to like a 13 kilojoule per mole. So it will be still 5 kJ per mole less than without the catalyst. But if you use a biocatalyst, it goes to only 5 kilojoule per mole. So there's a lot of energy activation that biocatalysts provide to the chemical reactions. Okay, these biocatalysts are known as enzymes. But what are they? Are they metals? Uh, they are proteins. Because if you know from my previous lecture, we are all made up of proteins. So they are also proteins. Some of them are simple proteins, some of them are conjugated. Okay, conjugated means they have something else with them. Sometimes iron is with them. So iron, hemoglobin, iron is with them. If you have made the chart of proteins, then there was a class of protein which act as enzymes. And if you are from engineering, please do it because it's important for you. So this was the introduction to the enzymes. Enzymes are proteins basically. They are a class of protein which could be simple protein or they could be a combination, and that is called a prosthetic group, as you know, cofactor. So they don't only accelerate the reaction, but they also drive a reaction to completion. Okay, at normal room temperature, no heating is required. So, for example, if there were no catalyst in our body, if the enzymes weren't there, the energy required to perform the reaction will burn us into dust. Can you take my line seriously? It's not a joke. The amount of energy, the energy of activation that enzymes provide us from head to toe to perform these reactions. Without the enzymes, the kind of energy we will be absorbing to do the reactions will burn us into dust, charcoal, animal charcoal. So they provide a lot of energy and they do the reaction without actually increasing our temperature. Okay. All biological reactions are enzyme catalyzed. Enzymes are positive catalysts. All right. Now, before I speak to you about the nomenclature, about the enzyme thing, I will also want to add here my personal thing. Okay. I'm taking a medicine, and the medicine is for high blood pressure, hypertension. What it does, it blocks the activity of enzyme, the angiotensin. It's called angiotensin 2 blocker enzyme. It's also called ACE blocker. So if you are taking ACE blocker enzymes, you cannot get coronavirus. Yes, because the enzyme actions are also helping the coronavirus to be contracted and other viruses. So enzymes are basically performing in our bodies, but the medicine I take is just slowing down the action of enzyme which cause absorption of sodium from the diet. Because sodium is bad for older people, if you know. So most of the medicines are also some enzyme blockers or inhibitors, supporters. Okay, you can also take enzyme outside, like you can manufacture, prepare enzyme as tablet, and then you can take it. It does not normally our cells make it, but it can be made outside the body as well. All right. There's one enzyme called CoQ10. CoQ10 enzyme, the cell mitochondria, they use this enzyme to convert energy into ATP. So as you get older, your body, your liver doesn't produce a lot of CoQ10. So you can take from outside and like that. So there's many enzymes, okay? So enzymes have name uh, with the suffix, just like all organic compounds. Alcohols have ols, aldehydes have als, carbohydrates have O's. Well, enzymes, their suffix is A's. A-S-E. As you can see over here, A's is the suffix. It comes at the end of all enzymes. So if any chemical that names with O's is a glucose, is a carbohydrate, but if it ends with A's, it's an enzyme. Okay, but the prefix can be of two types. Okay, the chemical substance on which enzyme acts is called substrate. Okay, let's say sucrose. Now sucrose is a disaccharide. To break sucrose into glucose and fructose, you need an enzyme called sucrase. Now sucrose is substrate, and the enzyme which acts on that substrate is called sucrase. So the prefix is either the substrate on which the enzyme acts or the type of action that that enzyme does. So sucrase is basically hydrolase. You know, it causes hydrolysis. Okay. So if it is doing oxidation, okay, oxidation, oxidase, hydrogenation, hydrogenase, reductation. Can you tell me? Reductase. All right. So the name of an enzyme comes from two sources. Either the kind of chemical substance on which the enzyme is acting. The enzyme that act on maltose is called maltase. Sucrose is called sucrase. So it depends upon what substrate the enzyme is acting on. But since one enzyme can do different functions and one substrate can have different enzymes, so this idea is not very cool. So IUPAC has changed this idea and they now name the enzyme not by the name of the substrate but by the name of the chemical reaction that that enzyme does. As mentioned, if the enzyme is doing oxidation, it's called the oxidase. The enzymes which do the reduction are called the reductase, and so on and so forth. If I have an examples here, yeah, dehydrogenase. Can you guess what it does? It does dehydrogenation, removal of hydrogen. Hydrolase, adding water. Oxidase does oxidation, but these actions occur inside our body. And this sucrase maltase is from the substrate example. There are many other examples in your textbook, so kindly refer to those and you can increase or decrease examples as per your wish. Okay. Classification of enzymes. So let's see. The first type of enzyme is this. What is this? Oxidoreductase. Now, if you guys remember, you know oxidation, you know reduction, adding oxygen or removing oxygen, adding hydrogen. Those enzymes which catalyze such reactions are called oxidoreductase. You can see in this chemical reaction, ethyl alcohol, CH3, CH2, OH. Okay, two hydrogens are removed from it. Removal of hydrogen is also called oxidation. Okay, so also dehydrogenates, they're the name by the action of the enzyme. And more types, transferase, which transfer one substrate from one form to another form. For example, if you see L-aspartic acid, and these are fatty acids, okay, and they can convert into oxaloacetate or glutamic acid. These are used in our body in the cellular respiration. I don't know much biology, but these actions take place in our body, and the enzyme aspartate aminotransferase does the job. Okay, so it's not French language; it is just the suffixes like that. Then you can see hydrolases, hydrolytic reaction that involves action of water. Amylose, converts to glucose by the action of amylase. So amylase, by classification, is not a transferase; it's a hydrolase. Okay, if you remember these names, it might come as an MCQ. That what kind of protein, what kind of enzyme is lipase? Is lipase a dehydrogenase, or is lipase a hydrolase? It's a hydrolase. It does hydrolysis. Because lipids are made from fats and glycerols, so lipase will separate them. So if you eat lipids or fats, you need the lipase enzyme. The lipase enzyme will break them down into fatty acids and glycerols for you. So what happens in our digestive tract? We eat macromolecules, polymers, then enzymes cut them into monomers. Bloodstream goes back to our cells and they become again the polymers. Then you can see protease. Protease converts protein into amino acids, etc. Lyase, the double bond, the action on double bond, addition reaction. Example, if you know, threonine is an amino acid. Now, to convert the threonine into glycine, there is an enzyme, okay, threonine aldolase. And isomerase, can you guess, which converts one isomer into another isomer, like L-alanine into T-alanine. Alanine is an amino acid. And ligase, these are those catalysts which basically which control the condensation reactions. Okay. So what are the properties of enzymes? Okay, enzymes basically are proteins. Okay. Uh, so whatever property or whatever damage or whatever behavior proteins will show, enzyme will show the same. So in aqueous solution in water, enzyme will lose their activity if they are kept in water for a longer time. Okay, they also inactivate by any action that coagulate protein material. Now, what is coagulation? Mahmoud asked this question. If you leave a protein for some time, it starts to denature. This denaturing is known as coagulation. So if anything denatures proteins, also denatures enzymes. Okay. So if you have an apple, and it has skin all over it, the skin protects it for some time. But if the skin is removed, what happens? That the action of the enzymes or bacteria denatures them. This is called coagulation. I hope you understand that. So, a lot of heating, a lot of washing, a lot of alcohol, salt, heavy materials, some mineral acids, they all can damage the activity of enzymes. Heating, okay, a lot of heat will also affect the enzymes. A lot of cold will affect the enzyme. So human cannot take a lot of heat, a lot of cold. Our enzymes work best at 98 point, yeah, the normal temperature. That is where they act the best. And they act the best when the pH is slightly above 7. Yeah, they like the basic pH. They don't like the acidic pH at all. If your body has more acid in your stomach, what happens to you? Acidity. Because your enzymes stop digesting your food because they are not happy at a pH less than 7. These are the properties of the enzymes. Okay? So what are the best temperatures? 37 to 50, which means 97 degree Fahrenheit to 107 degree Fahrenheit. Above or below, there are two things can happen. They may be temporarily not working, or they may be permanently not working. Yes. You might have heard about high fever, sometimes high fever cause some permanent damages. It's because the kind of enzymes are damaged permanently. Okay? Beyond this temperature, they lose their activity. Okay? And at low temperature, they don't lose it. They just slow down, they regain. But at high temperature, they can lose the activity forever. As mentioned, okay, enzymes, different enzymes have different pH. That's not that they all need to be basic, but in general, slightly basic is good. So, my dear friends, I repeat for you, enzyme pepsin in need is 1.6 pH is good for it. Trypsin 8.2 is good for it. Our stomach pH is also controlled by HCl. So somewhere we need a lower pH, sometimes higher pH, but generally more the basic side. Enzyme concentration, a lot of enzyme, a lot of activity, a lot of rate. Okay, so as I mentioned, CoQ10 enzyme in the liver, what it does, it makes more ATP for you. So if you take 20 gram CoQ10 and then you take 200 gram CoQ10, you will feel a lot of ATP in you. And I am personally, I have been using CoQ10 as a supplement, and I used to put a lot of energy in me and less hunger as well. But I don't recommend to all of you to take CoQ10 enzymes. All right, so there are other factors as well. So enzymes are, this is a simple topic about enzymes. You can just write from the slide right here, or define enzymes, some classifications, some example like properties and factors. That will be all for you. Okay, so enzyme is a simple and easy topic which you can fare. If you don't want to fare, up to you. You can simply study it and learn from it. So today's topic is about enzymes. Kindly work on it, because this is also in the test. Tomorrow we do vitamins, and on Friday we will have our last lecture about digestion. So study through, also prepare for your test as well. Thank you so much. If you haven't sent me your email, do send me. And number one, number two, I will make a tutorial video tomorrow about how to take the test. So I just brought all my laptops today. I will be my own student, and I will also do first try on myself. I have some friends helping me, but I will also do it, and then I will make a video for you tomorrow. Thank you so much. Stay home, stay safe, have a great time, and prepare for the test. Goodbye.